So a little bit about the global centers. The global centers promote and facilitate collaborative and impactful engagement of the university's faculty, students, and alumni with the world to enhance understanding, address global challenges, and advance knowledge and its exchange. So for the fall term, the Global Centers is part of the university initiative to support international students and students who are living outside of the United States. It's made it possible for students in 65 cities around the world to access high-end study spaces to convene, connect, and to be supported as part of the Columbia community. In addition to these spaces, the Columbia Global Centers is developing programs and events, such as this week's series of computer workshops. So again, this is the Intro to Linux workshop. On Thursday, we'll be doing part 2 of the series, which is the Intro to Scripting workshop. And then next week, I believe next Thursday perhaps, is the Intro to High Performance Computing workshop that completes the series. That's the third part of the series. We also have a Python for Beginners workshop there will be a session tomorrow at 8 a.m. and another one next Monday at, I believe, 4 p.m. Eastern time. So we welcome you to, if you're interested, register for those courses. So about myself, my name is George Garrett. I'm the manager of Research Computing Services at Columbia University IT. A lot of what we do is maintain the high performance computing services at Columbia. We have a couple supercomputers that we run and operate. So one of the things you can do if interested is you'll learn how to use it next Thursday if you attend that workshop, and then you can actually apply for a free account if you'd like to get extended access to these resources. So we're also a resource for you to learn more about research computing services in general. So with that, I'd like to introduce our instructor and our helper. Our instructor is Ksenia Radeva. She's a senior system engineer on the Research Computing Services team. And our helper for this workshop is Cesar Arias, also a senior systems engineer on our team. So as we go, we're happy to answer questions. If you have any questions or issues, please type them in the chat or the Q&A, and we'll address them as we go. So thank you again for attending, and I'll hand it over to Ksenia.
Thank you, George. Welcome, everyone. Thank you so much for joining us and participating in today's workshop. Now I'm going to share my screen. I hope everybody can see the slides. We would like to hear why did you choose to attend Intro to Linux, and what do you hope to gain from attending the workshop today? Can you please type your answers in the chat box? Your feedback is very valuable and is going to help us to address those questions in the future. Cesar, my colleague, is going to monitor the Q&A and either let me know whether I have to answer a question, or he can type the answer in the Q&A. The slides are going to be shared with you with all the resources after the workshop. And this is part 1 of Research Computing Workshop Series, Introduction to Linux. And you can reach us at rcs@columbia.edu. The Research Computing Services is responsible for providing technology resources to support Columbia's researchers and the university mission to be a leading driver of research. RCS team is hosting workshops, consultations to teach basic skills for research computing, and provide all the support that is needed for the research at Columbia. Foundations for Research Computing provides informal training for Columbia University graduate students to develop fundamental skills for harnessing computation. It is a university-wide initiative. The Foundations program aims to create a computational community at Columbia, and that URL here on the slide, you can check the calendar, which has distinguished lectures, boot camps, workshops, Python user group. And today we are going to cover basics, Linux basics. On Thursday, we'll continue with scripting. If you're interested, you can sign for the workshops on Thursday. We have 3 of them starting at different time slots. And the slides are going to be shared, and we are going to have a hands-on session today. What is Linux? Linux is an operating system, and what is operating system? An operating system is system software that manages computer hardware and software resources and provides common services for computer programs. If we have to visualize this, graphically, you can see the user interacting with the applications which are sitting on the operating system and communicating with the hardware. A little bit of history. This is going to be quick. And Linux is related to Unix. Unix development started in 1969. 22 years later, Linux was released. And this dense history diagram shows what happened through the years and the evolution of Unix systems. If you're interested, at the end of the slides, we have more resources that you can pursue on your own. And Unix was created by developers for developers. Unix was designed to be simple and powerful. From the command line, you can perform actions and process text and run small programs even, just through a simple pipeline of commands. And we'll cover some of this today. Today for the workshop, we are going to use QNX at Columbia, the system. There are 2 servers, QNX Prot 01 and QNX Prot 02. After you log in to the system, you'll be on one of those 2 servers. And the user ID is going to be your uni. For Windows users, we have, you need to download PuTTY and then run PuTTY from your desktop to be able to connect to QNX servers. I hope that you already download PuTTY from the Columbia homepage. If not, we can provide the link in the chat for people who need this. And for Mac users, you need to look for the terminal. And if you type terminal, you'll find it here. Click on it, and this window that is here on my left side is going to pop up. I'm going to move this one just in case. And this is how Mac and Windows users need to log in to get on the QNX system. For Mac users, we are going to use SSH command, and then you have to type your uni at cunixcolumbia.edu. My Mac terminal is right here. It's already open, and I'm going to type SSH, and then my uni is AR2667 at columbia.edu. Actually, this is my email, and we are going to Cunix. And after I press enter, it's going to prompt me for a password. The password is your Columbia uni-related password that you're using for logging in your email. And if you notice, I'm typing right now and you don't see anything like dots or stars for the password. This is okay, because from the terminal, you don't see any changes and feedback. However, you can see that I'm already on Cunix prot 02 on one of the Cunix terminals. And for Windows users, you need to execute run putty.exe. And in one of the windows, there is a place where you have to specify host name. And the host name is cunix.columbia.edu. And the user is your Columbia unit. I wait a little bit to make sure that everybody can log in to Unix system, either from your Mac or Windows. And does everyone have access? If you have any issues, please let us know. Caesar, can I continue?
You can go ahead. Yeah, there's no questions or anything like that popping up, so I would say just go ahead.
Okay, we assume that everybody was able to log in on Cunix servers, and you're going to see the prompt, and this is the default prompt for our accounts, and we can make it a little bit more user-friendly with the following command, which is we are going to use ps1, which is an environment variable, and I'm going to type ps1 equal double, I'm not typing. Okay, ps1 equal double quotes /w $ space, and I'll close the double quotes and press enter, and you can see that now I ended with the prompt $. And everybody, after executing this command, should get tilde $, and you can get some unified prompt. And ps1 is an environment variable, /w is the current directory, and the prompt $, is a conventional prompt symbol. And most importantly, when typing commands, either from these lessons or from other sources, don't type the prompt, only the commands that follow it. And this is the name of the current directory, as you can see. And tilde is a special character, which we are going to talk about a little bit later. And there are two important files that you can set up, .bash_profile and .bashrc. These two files can be used to set up your environment automatically when you log in. For example, on the cluster, we specify some modules that we want to be loaded every time when we log in, and this is the place to do this. But it's beyond the scope of this session, and I'm not going to talk in details about the files, but this is possibility and you can pursue it on your own. And let's try the first command, which is pwd, and it stays for print working directory. And if I type pwd, we'll see the directory path to my home directory. As you can see, the name of my home directory is AR2667. This is my uni. And this is the directory path, which starts with /, which is the indication of the root directory. And this is how the directory structure looks. On the top, we have the /, which is the indicator for the root directory. And then you have a bunch of subdirectories and another subdirectories. And you get to the directory where you want. And with the command ls, we can see the content of the current directory. If I do ls, I can see what I have in my home directory. I have some files and subdirectories. On the terminal, you can adjust the color and the size and font of the characters. And for example, I have the regular files in black, and the executables are with green. The blue is for subdirectories. ls has a lot of flags or options that can be used with. And for example, one of the flags is -l, which is going to give us a long list of the content with more information. And if I type ls -l, this is the same files and subdirectories in my home directory, but in addition, we have more information, and we are going to talk about this a little bit later, what each of these columns represents. A very useful command is man command, and you can use this with any other Unix command. For example, if we want to see what are all the flags and options in ls, we can type man -ls, and you can see that there are many different options, and there is a description what it means. For example, -a, lowercase a, and if you notice you should pay attention because there is a difference between uppercase and lowercase letters. We have lowercase a, uppercase a, b, and one of the flags is -a. This means that shows everything in the directory, including the files that starts with dot, and we'll check this later. We already try -l, which is use a long listing format. And you can decide which one of the flags and options that are available for this command to use it. To get out from the man command, you have to press Q, and I'm back to the command line. And I can check with pwd that I'm still in my home directory. And we can combine different options. For example, we try ls -l, And we can do ls minus a, which is going to give all the files, including the ones that starts with dots. And we can do a long list, adding L for long list. And now we'll see all the files in my directory with the additional information, which is the permissions, the user name, the group where I'm member of it, and the size of the file, and the last modification for the files and the directories. Do we have any questions, or I should continue? It looks like.
You can continue this. There's just one question, but it's posed towards George, and it may be with an issue with a user being able to get into QNX. So there's nothing else. Xenia, you can keep going.
Thank you. And the next command is cd, which stands for change directory. From the place where we are, we can move forward or backward. And for example, if I execute cd space /, this is going to place me in the root directory. And let's see. With pwd, I'm confirming that I'm in my home directory, and with cd space /, I can move to the root directory, and pwd, it shows that I'm in the root directory. And there is a few ways that we can go back to our home directory. One of them is cd with no arguments. If you just type cd change directory nothing, it's going to place you back in your home directory. And I can confirm this with pwd. You can see that I'm back in my home directory. And another way to get to the home directory, it's cd space tilde, and we'll go over this a little bit later. And what is the meaning of these two dots, dot, means the directory above this one, which means that if I'm in my home directory and I type cd space dot, will bring me one level up, which means that I'm going to get to the subdirectory A. Let's try this, cd space dot. And if I do pwd, you can see that right now I'm one directory up in directory A. And what is the meaning of a single dot? Single dot means this directory, and probably this exercise doesn't really make sense, but the power of single dot is very significant, and we use this very often when we try to copy stuff from one directory to a current directory, and this is how you indicate that you want to move stuff here in this directory and the dot, instead of typing the whole path or using different commands. And I'm going to go back to my home directory. And with pwd, again, you can see that I'm here. And if I do cd dot, it's not going to change the position because I'm telling the computer, change the directory to this directory that I'm in already. And if we check with pwd, we can confirm that we are still in our home directories. And tilde This is another way to get quickly to our home directories, because usually when you have a project, you create many different directories and subdirectories for different projects. And if you are in one of the projects and then you decide to go back to your home directory because you want to access a different directory, the easy way is to type cd space tilde or cd no arguments, and you automatically will land in the home directory. And if I do, for example, let's go again to the root directory. I'm changing my place to the root directory, and if I type cd space tilde, it will bring me to my home directory again. And now we are going to talk about paths. There are two different paths. One is absolute path and the other one is relative path. The absolute path starts from the root directory, and then you provide the exact structure from the directory paths with all the names and separate it with slashes. But the first slash is the root directory, and the relative path doesn't need to start from the root directory. It can start from your home directory and then continue typing without slash in the beginning. And if I try to cd to temp, which is a directory, however, I'm in my home directory and I don't have this temp created, and if I try to go there, bash is going to inform me that this directory doesn't exist. And you can see that bash cd to temp directory, no such file or directory. However, if I try to cd to /tmp, this means that I have to go to the root directory, and instead of going to U subdirectory, I'll end in tmp, where is our file actually for today's workshop. And if I do /tmp, which is the absolute path, I'll end in /tmp directory, and over there, this is the content of the of this directory, and this is our little file that we are going to use today for the workshop, and we'll copy from the temp directory very soon. And let's go back to our home directory again, cd no arguments. We'll check that we're in our home directory. And now we'll use the command cp, which is copy this file to our current directory, and /temp kids is the absolute path to the file. Let's try this, cp /tmp /kids, and then space, and the dot is the current directory, my home directory. I'm going to make a copy of this file kids into the home directory, and I'm going to press enter. And even though that you don't see anything that it's happened, actually the action is taken, and the cp command made a copy of kids in my home directory. And let's check ls. You can see that the file is right here. I hope that you're able to follow my commands. I hope that I don't go too fast, and all of you got a copy of the file in your home directory. If you have any issues, please let us know. And another command that we are going to talk about today is RM. It stands for remove, and it's very powerful command, and we should use it very carefully because if we remove files or directories, there is no trash can, and we are going to lose these files. There is no way to go back to the trash can and pick it up from there. It will disappear, and you lose the information. And I advise to use RM with one of the flags, -I, which is for interactive. And I have an alias created already for me, where I assign RM to be RM -I, and is going to ask me a question whether I'm sure to that I want to remove this file or directory. And let's create some file that we want to get rid of it. And we are going to make a copy of the file that we just copy from the temp directory. And we are going to name it junk. And with ls, we can check that in addition to kids, we have junk. And now we are going to remove junk, rm junk. And now, because I created this alias with RM -I for interactive, it's saying remove regular file junk, question mark. And I'm going to say yes. And then we can check the content of the directory and see that the file junk that was here disappeared in my home directory because I remove it, and there is no any way to get back junk, but we have a copy of kids and we are fine. Another command that is very frequently used is cat. It stays for concatenation. You can concatenate many different different files, text files. And also in our case, we are going to use cat to see the content of the file. And let's type cat kids. And this is a small poem from the author John Keats. And we are going to perform some actions on this file later. And another command that is used frequently is the command mv, which stands for move, and they're used mainly with two different cases. For example, in this case, we want to rename the file kids into kids. It was misspelled, and now I'm going to change the name of the file that we have with this command. And we can see with ls that the file got renamed here. Before it was KEETS, and now we can see that the file is renamed to KEATS. And another way to use the command mv is when we physically move one file from one place to another, or move even a whole directory from one particular place to another. And let's create the temp directory that we checked earlier, and we saw that it doesn't exist. And to create a directory, you can do this with mkdir, make directory. mkdir, and I'm going to create TMP. Please notice that this TMP is different from /TMP. /TMP is under root directory, and this TMP is under my home directory. And if I create this temp, we can check with ls to see whether the directory is created, and the directory is right here. And now we want to move the file kids into the directory TMP. As you can see, both the file and the temp directory, they're in my home directory. And with mv command, I'm going to move the file into the TMP directory. And if we go to TMP with the command cd, which stands for change directories, and we list the content of the TMP, we'll see that the file is there. And we can confirm that we are in the TMP directory, which is under my home directory right now. And we learn about rm command, which was we were able to remove files. If you want to remove a whole directory, there is another command, which is rmdir. And with this command, you can remove a whole directory, but you have to make sure that the directory is empty. Otherwise, if it's not empty, rmdir has additional files and options that you can specify, like a recursive, and you can remove with the recursive option all the files first and then remove the directory. And let's see where we are right now. pwd is showing that we are in the temp directory. We are going to move the file that we'll need later back to our home directory with the ... the double dots means that are one level up, and the kids file will land back to my home directory. And if we check the content of temp is empty, then we need to go one level up, and this is going to place us in our home directories. And from here, I can use rm directory to remove the temp directory that I recently created. rmdir tmp. And as you can see, nothing happened visibly, but if I check with ls, the TMP directory is not on the list anymore. It was here before, now it's gone. And there is no way for me to recover this. And there are more useful commands that you can check who am I, and it's showing that this is the user AR2667, and who am I is similar command, but is giving more information. For example, you can see that this is me, and I was logged today, October 27th at 12:11. And this is the network from where I'm joining the, from where I logged in. And another commands are ID and groups. You can see with these two commands, for example, the different groups that you are member of, or if you want to see my ID, if you type AR2667, you can try it either ways with mine or your uni. You can see all the groups that you are member of. And you can see that I'm member of RCS group, Moto RCS, Haba RCS, and groups is another way, it's a cleaner list. Group AR2667 is, okay, maybe I didn't.
You got the yes?
Yes. AR is giving you that my uni, the ID, is a member of all these groups, which basically are the same one here. And the who command displays a list of users who are currently logged into the computer. And there is another command, just W, which provides the same information, but also displays additional data and statistics. And let's try who is logged in. And you can probably see some of your unis here. And some of the users are logged in on the other server. And with W, you get a little bit more information. For example, you can see my uni and it's saying that I'm running the command W right now. And I was logged from here, and the time and some additional information about the CPU. And this is the W command. And bash is a shell. It prints the prompt and interprets what you enter. The shell is basically a program where users can type commands. And the most popular Unix shell is bash. Bash is the default shell on most modern implementations of Unix and in most packages that provide Unix-like tools for Windows. And it is useful because it gives you a feedback. We already tried with temp directory when it was not existing. Now we can try to do this with a file. And if we type chats, it's going to prompt me that there is no such a file in my current directory or directory that its names chats. With the up arrow, you can retrieve commands that you already executed. For example, this is the last one. Before that, I did W, who, groups, and you can execute those commands again. And if you go with the left arrow, you can move the cursor left and right. And for example, we want to change J to K because I on purposely made a mistake. And now if we execute this, we'll see that the file kits is in the home directory. And there are many other shortcuts. This caret sign means hold down control button on your keyboard. And for example, if I go with upper arrow up, I'll get the command that I just executed. And with Control A, you can go in the beginning of the line. With Control E, you can go at the end of the line. And with Control K, you can delete the whole line. And there is many more useful bash commands which can speed up your work and make your life easier. And this is what I use all the time, the tab completion. For example, if you do ls, it works for commands and file names, and it is really powerful. And if I type K and then tab, it complete the whole name of the file. If you have more than one file or directory starting with the same letter, you do twice. And for example, is showing that in my current directory, I have workshop, workshop AR, workshop old, and I can choose in which one to go instead of typing workshop the whole word. And let's go and back to our ls-l command. And we saw this earlier. And the first column is showing the file type and permissions. Then is the link count and the user name, the group of the user that is member of, the size of the file, and the date that it was last changed, and the actual name of the file or the directory. And the first dash here, it shows what is the file type. If it's just a dash, it means normal file. D stands for directory, and L, if you see L, it means link. Sometimes we create soft links to some directories. I don't have any right now here in my home directory. And there is other characters, but we are not going to talk about this. The permissions are after the type file. As you can see, there are 9 spaces, and there we call them 3 group of 3, because the first 3 positions are for the owner of the file, and the owner can have read, write, and execute permissions. For example, this file that is in green is executable, and you can see that the owner has a reading, writing, and execution permissions. And the second group is for the group that the user is member of, and the user gave reading and executable permissions for this file. And the third group is for everybody else, also is allowed to read the file and execute it. And this column indicates how many links, but we are going to ignore links today, and we are not going to talk about this. Then is the user. Here in this column, you can see my uni, because this is the ID that owns all these files and directories. And then is the group that owns this file, is user in this case. And the size of the file is right here, and is listed in bytes with different flags in ls. You can use also kilobytes, megabytes, gigabytes, terabytes, depends how big is your data, and you can see it with -h flag for ls is for human readable also. The last time the file was changed is indicated here. And the last column is the actual name of the file. And the permissions, we already talked about the 3 group of 3 with read, write, and as I said, there are 9 permission settings and 3 groups of 3 Again, I'll repeat that the first group is for the owner, the second one is for the group, and the third one is for everybody else. And yeah, this is owner, group, and everybody else. And what's the dot means at the end? It is indicates the presence of an access control list, and its additional permission layer. If you're more interested, you can read in the resources that we are going to provide at the end. And let's try another useful command, date. For example, if you run some experiments and you put the executables in some small shell script, and you need to know when it was started and when the process finished, you ask the shell script to send you email with the date and time, and you know that this process took 6 hours or 12 hours, and then you can adjust your work and plan how to proceed with your experiments. And date returns today's date and time. And we can save this in a file, for example, with redirection, the greater sign, we can do date and save the output from the standard output in a file, the date. And if we ls, I use LTR combination of flags for ls, which is very useful because lists everything and in reverse order and time. And I can see the latest file that I created. And we can see cat, the date, and we can see that we saved the output from the command in this file. And we can do the same with ls-l if you want to save the content of your home directory. You can do this. And if we look at my home, you can see all the files with the information that is from ls-l command. Another command which is very powerful and is used very often from the command line. If you want to sort the content of a file or output from another command, you can do sort and is going to sort alphabetically all the sentences in the file inside. And sort has a lot of different options and flags. You can check and see what is available with man command. Man is applicable to any single command in Unix. And there is a numerical sorting and many more things. And now we can use input redirection, where we'll get the content from the file and as input to the sort command, and it's going to do the same thing, but this is a different way to do it. And we can do sort it, and we'll get the same output. This is just two different ways, but this input redirection can be used for bigger programs or different commands when you have some input, and you can give it to the program that way. And we can do it even with less sign. You give the input from kids to sort command, and then with a greater sign, you are going to save it in a sorted file. Let's do this. Sort less kids, and then we are going to save what you see on the screen in the sorted file. And if we take a look with the command cat that we learned earlier, sorted, you can see the same content that was displayed on the screen. And if you use double greater sign, this is going to append to the existing file. For example, if we look at the content of the date, we can see that we already saved the date and the time. And if we execute date, greater, the date, and then we check the content of the date, we'll see that in addition to the first entry, we have another line from 1255 appending to the existing file. And this is very useful for log files when you want to monitor something and save values, and there is a script that runs some process and keeps writing in the same file, and then you can check later what's going on. And grep is one of my favorite commands because with grep you can find things in text files. Basically, now we are looking for the pattern planet in the kids file, and planet in the file, and it's going to tell me that there is one line that contains the word planet in the file. And when you need to process text, grep comes very handy. And also remember that grep has many other options. You can see them with man command. There is -i for ignoring case sensitive when you look for patterns, and many more. There is -c for regular expressions, and there are a lot of things that you can do with this command. And pipes allowed us to connect output from one command to the input to another command. And we are going to combine the two commands that we learned today. If we type cat kids and we pipe it, the output from this command to the next command, which is grep, is going to give the same answer, and it's another way. It looks redundant to do more complicated things when you can use just grep to get the same output, but with the pipes you can create a very complicated executable things, and instead of writing a shell script or another program, you can do it directly from the command line, and it's really useful. And about editing, there is no obvious choice for editors to use from the terminal. There are three of them. VI is a simple but difficult and at first, and there is a learning curve to start using this editor. Emacs is powerful but complex, and Nano is simple but not really standard. And Nano is the editor that we are going to use for this workshop and next week, next Thursday for the shell scripting. I'm going to open Nano, the file kids, and you can see this is how it looks. This is the content of the file, and I can edit the file. And the caret sign means, again, hold down Control. And for example, with Control E, I can go at the end of the line, Control A, with in the beginning, Control K deletes the whole line, Control and if after I made the modification and delete the line, I can save the file now. And this I can do with Control O, and is asking file name to write kids, and I say yes. And then Control X if I'm going out of the editor. And less is another command that is not to edit files. However, if the file is really big, it's very useful because you can see the content going up and down easily, even with scrolling. And let's do, this is one of the logs in varlog directory, the messages. And if I open this, you can see that there is a lot of information, and it's easy for me to go back and forward. You can search also for some patterns. And for example, when you are in less with space, you can go to the next page, with B to the previous page. With G, you go in the beginning of the file. With Control G, displays the location. As you can see, it says that is varlog, the messages, lines between these, and gives you additional information. You can search with backslash, and for example, if you look for BIOS pattern, you can see it's highlighted all over. And to get out from less, again, you need to press Q, and you are back to the command line. And quickly, this is another command, sleep. It says, it gives a command to the computer to sleep for 5 minutes and then go back to the command line. It's more useful than it seems. It's used usually in shell scripts where you have some process and you want to put this process to sleep for a while and then execute it again. And just for fun, we are going to use the command echo, which is going to print hi on the screen. And again, in combination with sleep and echo in the shell scripts, you can tell your processes what to do, and also send you some information with echo. This one is going to sleep for 5 seconds and going to print hi on the screen. And this is how you can combine two different commands with semicolons to separate it. And if I do sleep 600 seconds, it's going to take longer, but I can use Control C to stop the running process. And with exit, you can exit the terminal if you'd like. We are at the end of our workshop. There is other ways to log in out with logout and Control D. And if you have any questions, please let us know. And we have some resources at the end of the slides that are going to be shared with you. And if you're interested, you can pursue on your own. Cesar, is there any questions?
Nope.
No.
That's right now, not seeing any questions. It's been pretty smooth.
Okay. Then thank you so much for attending the workshops today. And please join us Thursday for Intro to Scripting.
Awesome. Thanks, Ksenia.
You're welcome. And I'm going to stop sharing unless somebody has questions. I don't see anything. Okay, bye-bye.